So we are talking about right triangle trig. Almost everything we talk about today should be a review of geometry, but I know that geometry was way back when, 2 years ago, and you know, could be a little bit tricky to remember way back when. So we're going to dust off your skills, plus we're going to add in a little pre-calc along the way. Cool? So we already said we remembered from the do now that when we were talking about a triangle, the long leg across from the right angle was the hypotenuse, right? When I'm talking about a specific angle of a triangle, I use the Greek letter theta to represent the angle. So like we're used to seeing the variable represented as x, but when we're talking about an angle, just so that it's not confusing, just to make it a little bit easier to understand, instead of using an x for an angle, we just use the symbol, the theta, which is like a 0 with a line through it. It's from the Greek alphabet. It's one of their letters. That's our representation of an angle. So if I said my angle that I was looking at was in that top corner, the side that's across from the angle, so if I'm looking at it, if I go directly across, that's my opposite side. The side that touches the angle, or the side that makes up the angle. So here, if I was looking at measuring that angle, the one that's not the hypotenuse that makes up the angle is called the adjacent side. Is that ringing a bell? Maybe kind of a little bit. Have you heard those words before? We also know that the word adjacent kind of means that they're next to. So it's the side that's next to the angle. The opposite side is the one across from the angle. The hypotenuse is always opposite the 90-degree angle. So the tricky thing about this now is if I decide to move my angle. So if I say, okay, now I'm going to use my angle here, my opposite side and my adjacent side switch. So they're not always going to be the same. It depends on which angle I'm looking at, because now looking at a triangle with the angle in the bottom, my opposite side is over here, and my adjacent side is down at the bottom. So if I switch which angle I'm asking you about, that switches which side is the opposite and which side is the adjacent. So the first thing we want to do with any of these problems is always label which sides we have, because that's going to help us decide which trig function we're going to use. Okay with the labels? All right. So the other thing you probably kind of remember, come on. When I say the word SOHCAHTOA, does that jog anything in your memory?
I remember it, but I don't know what it means.
We don't really remember what it means, right? But it sounds kind of familiar. It's an easy way, it's intentionally made or written so that it's to help us remember which trig functions go with the opposite and the hypotenuse, or the adjacent and the hypotenuse. Do you want to hear my fun story that will help you never ever forget SOHCAHTOA? Alright. So once upon a time, there was this girl who was madly in love with this guy, but her father really wanted her to marry the prince from another kingdom. So she went to her grandmother and she said, "Grandma, I can't marry this man. I'm in love with somebody else." And her grandmother said, "At the next full moon, go out into the forest and build a fire, and all night you must dance around the fire and chant Sokotoa, and it will convince your father to let you marry the man of your dreams. So she waited for the next full moon. She went out, she built the fire, she started dancing and chanting Sokatoa, 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 Sokatoa. Despite how tired she got, Sokatoa, 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 Sokatoa. And she fell asleep. And her father made her marry the prince. The end.
It's like a true story.
100% true. Yeah.
Did you ask if this is true?
Yes. So, anyway, now that you will forever remember Sokotoa, Sokotoa is our way of remembering our three main trig functions and how their ratios are set up. So we have three trig functions. We've got sine, cosine, tangent. Is it all coming back to you? It's all coming back. It's beautiful. So when we're talking about the so part, we've got, it's our sine function. If we're writing the entire word, S-I-N-E, if we're abbreviating it, or the way you see it in the calculator, or when we're writing actual math, it becomes S-I-N parentheses theta. Now, the most confusing thing that I think everyone makes mistakes with is when they're looking at this, they're looking at it as sine times theta. But it's not. It's the sine function, and we're plugging theta in. So it's very, very similar to saying f of theta, which we're used to looking at as a function where we're plugging into. The only difference here is that sine, cosine, and tangent were showing up so often, they had so many uses that instead of just calling them f or g or h or a random letter, they gave them a name and they programmed them into the calculator so that we don't have to go in and type in the entire function and plug the theta into every variable. We can hit the button and the calculator already automatically knows to plug the angle in for us, instead of us having to go in and plug it in for the entire equation. So when you see sine of theta, it's an actual function that we're plugging into. In order to get the sine, or when we're talking about the sine is our opposite over our hypotenuse. So that's what the O and the H stand for. So sine is opposite over hypotenuse. Should have written this the other way, but so we get opposite over hypotenuse.
And that's just the length, right? That's the length of the side.
Yes. Yes. So if we were looking at a triangle, and I was going to say that my angle was up here, I had a 3, 4, 5 triangle. That's one of my special right triangles. If I wanted to know the sine of the angle, sine is my opposite side, which opposite of my angle is 4. My hypotenuse is always opposite my 90 degrees, which means this one's my adjacent. So if I want my sine, all I would say is that it is 4 over 5. So in this situation, the sine of the angle is 4 over 5. Not too bad. So then the ka in Sokotoa is cosine, the adjacent over the hypotenuse. So if we were writing the entire word, cosine, when we're going to write it as a math function, we abbreviate it to COS. I'm just going to squish it down here. Cosine. And our cosine is our adjacent over our hypotenuse. So to this day, when I solve these problems, the first thing I scribble down is SOHCAHTOA, because it's easier for me to look at SOHCAHTOA and pick out, oh yeah, right, cosine is adjacent over hypotenuse, or sine is opposite over hypotenuse, than just to memorize which one is which. I don't know, it just helps me think about it. So the first thing I always do is write that down, then I label my sides, and then I go on from there. But cosine, we just said, is our adjacent over our hypotenuse. So that means if I'm looking at this same triangle, the cosine of the angle is going to be 3 over 5. And then the TOA stands for our last trig function, tangent. Tangent is abbreviated TAN. And our tangent is our opposite over our hypotenuse. Oh, yes, you're right. Good thing you're paying attention to the TOA. Our opposite over our adjacent. So then if I'm going to find the tangent of my triangle, my opposite side is 4. My adjacent side is 3. If I had fractions that weren't super simplified, I would simplify them. If I could reduce them, I would. Those are all good. So they're just asking us to set up our ratios. That's all stuff you sort of seen in geometry. Yeah. So the pre-calc that we're going to add in is our 3 trig functions also have reciprocal functions. So we have, for each trig function, we have a reciprocal trig function. And reciprocal just means, remember to flip it. Big fancy word for flip. So my first reciprocal function is secant. My second reciprocal function is cosecant. And my third is cotangent. Now, it would make perfect sense that sine and secant go together, but has anything in math ever made perfect sense? No.
No.
Naturally. So naturally, sine and cosecant are reciprocals, and cosine and secant are reciprocals. So if we're looking at secant, we abbreviate secant as SEC of the angle. Secant is the reciprocal of cosine. So that means it's the same thing as 1 over cosine. Or if we're talking about it in terms of the sides of the triangle, instead of cosine is the ka in SOHCAHTOA, the adjacent over the hypotenuse. This would be the hypotenuse over the adjacent. Cosecant is abbreviated CSC of the angle. It's the reciprocal of 1 over sine of theta. Or we could say it's the hypotenuse over the opposite. Cotangent is the reciprocal of tangent, abbreviated COT of the angle. It's 1 over tangent. Or, instead of being opposite over adjacent, it would be the flip. So it would be adjacent over opposite. So sometimes we might be given different information where it's easier for us to set up the secant, the cosecant, or the cotangent. Just kind of gives us more opportunities, more information to use in order to solve these problems when we get to it. So what you're going to look at today, your problems are going to look like this. It's going to say, find the ratio for each trig function. And then they're going to give you a triangle. And they're going to ask you to find the ratio. So now, if I ask you to find the sine of angle B, they're telling you this is the angle we're looking at, which means the opposite side is the 4, the adjacent side is the 3, the hypotenuse is the 5, and I like to always go in and label them. I also like to remind myself, so, toa, when I go and do it. So if I want the sine of angle B, I want the opposite side, which is 4, over the adjacent side, which is 3. If I want the cosine of angle B, cosine is my adjacent over my hypotenuse. My adjacent side is 3. My hypotenuse is 5, which makes me realize, hello, my hypotenuse up here is also 5. If I want my tangent of angle B, my tangent is my opposite over my adjacent, which is 4 over 3. So now I have two options. If I want to find my reciprocal trig functions, I can just use the triangle and remember that my secant is my hypotenuse over my adjacent. Or I can remember, okay, secant is the reciprocal of cosine. So if I want to find the secant of B, I just have to take my cosine fraction and flip it over. My cosecant is the reciprocal of sine, so I'm just flipping my sine fraction. My cotangent is the reciprocal of tangent, so I'm just flipping it. What if I asked you to find the sine of C? C is down here. Is the sine of C going to be the same thing as the sine of B? No, because now my sides are going to change, right? Now my opposite side is 3, and my adjacent side is 4. So my sine is going to be 3 over 5. Good. So you have to pay specific attention to which angle they're asking you for, because that's going to change which side is your opposite side, which side is your adjacent